All right, mathematicians, go ahead and have those pencils down, tracking me at 5. Thanks, Tiana, for already being there. 4. Thanks, Layla, for putting that pencil down right away. In 3, 2, 1, and 0. Friends, the good news is everyone nailed our focus question. Say, way to grow us.
Way to grow us.
That's a big deal, friends. 100% of us converted tenths to what? Hundreds. We were a little slow moving on the labeling equations, but we all got there. And I know, Amani, that on our test next week, when we get a question like this, what are we going to make sure to add to our equations, everyone?
Labels.
When I say go, you need to grab your binder, your paper, and a pencil, and walk calmly to a carpet square. Go. Okay, mathematicians. Let me see everyone's beautiful eyeballs. In a moment, this is where we're going to start to check and change our work. So Ms. Bunis is going to show you, Chris, make sure you're sitting down, dude. I'm going to show you some problems. You're going to check your work against what Ms. Bunis has on her paper. If you have the right answer and you have work shown like Ms. Bunis, give yourself a check. If you got a different answer than Ms. Bunis, check what I did, fix mistakes you had, and get that right answer. We're going to go chunk by chunk because my document camera isn't, we love it, but it's not perfect. So it's not going to be able to show you the whole page. So I'm going to show you the first 2 problems, then I'll move it down, and then we'll do questions 5 and 6. Okay, so here we go. Here's the first ones to look at. Check your work against Ms. Bunis's. Fix any mistakes that you have. Mathematicians, pencils down, tracking me. In 5, if you don't get everything on here, say that's okay.
That's okay.
No big deal. 4, 3, 2, 1, and 0. So I want us to look at the TV screen. So I see Justice tracking the TV screen. Ms. Bunis needs to make sure that it's actually the right problem. I see Jalea checking the screen. Same with Elijah. This problem is a meaty, juicy, really great problem, and here's why. We're going to read this problem, and we're going to annotate it together, Chris, and then I'm going to show you something I saw someone in Cornell do yesterday, and we're going to talk about their strategy. So, read with me all these words. One voice. Here we go. 1, 2, 3. Kelsey observed the park for some of its plants and trees. If 5/12 of the park is covered by tall trees and 3/12 is covered by smaller trees, what fraction of the park is not covered by trees? Okay, track up here. Your thinking job is how does this story or how does this equation match the problem, Tyree? Because this is what someone in Cornell did yesterday. And so, Glenard, as I write this equation, I want you to think, Cortez, how does it match what happened in the problem? Okay, look up there. 12/12. Where is that fraction coming from in this problem? Why did that person in Cornell choose 12/12? Because I want to see you thinking, Zoe, I want to see you thinking. Why did this person start their equation with 12/12? Where did that come from? I need 3 more hands. Where did it come from? Your pencil should not be moving. Where did this 12/12 come from? Because I don't see 12/12. I didn't annotate that number. Where did it come from? Hands down. Track Chris. So Vaughn tracked right away. Thanks, Key Michael, for setting that shine. Chris, where is this 12/12 coming from?
The 3/12.
What do you mean?
Why? Because 3 times 4 equals 12, so that means that the 12/12.
It has something to do with that fraction. That's not quite there. Track Justice. Cassie tracked right away.
Because the denominator is, both of them is 12, so you have to put 12, so you could single name.
Okay, so the 12/12 is a what? It's a fraction, it's a whole. This 12/12 represents the whole park. It represents the whole park. Where did the 8/12 come from? They got 8/12 from somewhere. Where did you see 8/12 in this problem? See, Cassidy's thinking about it, Elijah's thinking about it, Leonard is thinking about it. Look at the problem. Where did they get this 8/12 from? Hands down, Sage and Tyreek, you're gonna discuss it. Chris, you're gonna turn to track with Kayvon. Javelle, you're gonna turn to track with Jerome. The three of us are gonna be a group, and the three of you are gonna be in a group. Turn to discuss with a partner, where did they get 8/12 from? Go. Sage, make sure you're telling Tyreek. 20 more seconds.
I thought they were
Voices off, tracking up here in 5, 4, 3, 2, 1, and 0. Track Cass. Cass, where do they get this 8/12 from?
They get the 8/12 from adding 5, so that's like 8/12.
Why did they add those two fractions together? Why did that make sense in this problem? Why did that make sense to do in this problem? Track Elijah.
to see what the amount is for all the trees.
To figure out what fraction, the amount of all the trees. So I'm gonna write, and you should have this label too, covered by trees. What does that mean this 4/12 is telling us? If 12/12 is our whole park, 8/12 is how much is covered by the tall and small trees. What is that 4/12 telling us? What label do I need to add to it from this story? What label am I going to add to it? Christian?
Every
Got this.
You got it.
all trees that's covered,
What did the 8/12 represent?
they covered by trees.
Because how did I get 8/12? What fractions did we add together?
Oh,
Julia?
5 and 5, 12 and 13.
And those were the tall trees and the little trees, the small trees. So these are all the trees. So what fraction is the 4/12? Kayvon?
Oh, not covered.
Stop. You got it.
Got this right there.
Say it with like you mean it.
Not covered.
Not covered by trees. "30 seconds to add that label, and then I have a really important question to ask. Again, because this is so important, because we're going to see problems like this tomorrow and on the LEAP and for the rest of our lives. Why did they start with 12/12? How did they even know to start there? How did they even know to start there? How did they even know to start there? Track key, Michael. That's the whole part. Where did they look to figure out the whole fraction, Javelle?
So they added.
How did they know it was supposed to be 12/12? Where did they look to figure out this whole fraction? Yes, but what part of the fraction? The what? The denominator. So we can always look at our denominator to figure out that whole number fraction. Go ahead and flip your page to the back in 5, 4, track me up here in 3, 2, 1, and 0. Get your arms free. Okay, in a minute, Castelas, we're going to give ourselves a round of applause because what big thing happened today? What did everyone do? What did every single person do for that first problem?
Nailed it.
We nailed it. So let's give ourselves, get your hands ready. Tyreek, get your hands ready.